Now we are going to see what is function. A function f is a rule that assigns each element x in a set D exactly one element called a function. Now this is the domain and this is a codomain. Every element in the domain has the image. Then only you can say this f is called a function. Now we can calculate the domain and the range of any function. See now this function is f of x is equal to a 2x minus 1. So now we have to find the domain and the range. Now in this function we can substitute any value for x. We can substitute a 0 or plus or minus any number. We can define the function. Therefore the range, the domain of this function is the set of all the real numbers. At the same time, if you substitute any value for x here, for any real number for this x, you are getting again the real number. Therefore, the range is also the set of all the real numbers. So, for this function f of x is equal to 2x minus 1, the domain and the range is the set of all the real numbers. Now, this is one more example. F of x is equal to x square. Now, we have to calculate the domain and the range. So, in this function, f of x takes any value. You can substitute any value for x. You can define the function for any real numbers, 0, plus or minus any number in between minus infinity to plus infinity. We can define the function. Therefore, the domain is the set of all the real numbers. But the range is defined only for positive interval, 0 to infinity. Because if you are substituting any negative number here, minus infinity to 0, then f of x becomes only the positive. The range is only positive. There is no negative numbers in this range. Therefore, the range lies between 0 to infinity. Now, this is another example. F of x is equal to 1 by x square minus x. Now, here the function is 1 divided by x square minus x. In this case, the function is not defined. Clearly, the function is not defined for x is equal to 0 and x is equal to 1. If you are substituting x equal to 0 here, we are getting 1 by 0 infinity. The function is not defined. The same time x equal to 1 in the denominator, so 1 minus 1 becomes 0. Any number by 0, we are getting infinity. So 1 divided by infinity equal to 0. So therefore the function is not defined at the particular point 0 and 1. And any other point you can substitute. The function is defined. Therefore, the domain is defined in minus infinity to 0 and 0 to 1 and 1 to infinity except the 0 and 1. So this is the open interval. Minus infinity to 0, you can define all the values. In between 0 to 1, the function takes any other values. You can substitute any value. And 1 to infinity also. So except this 0 to 1. Therefore, the whole interval minus infinity to infinity can be divided into 3 parts. Minus infinity to 0 and 0 to 1 and 1 to infinity. Okay, this is an example of the domain and the range. Now we will see that function is, we have to check whether the function is even or odd. Now when you say the function is even or odd, if you replace x by minus x in the given function, you are getting same function, that is f of minus x is equal to f of x. Then we can say the function is the even function. If f of minus x is equal to minus f of x, then the function is said to be a odd function. Right? See here, f of x is equal to x to the power of 5 plus 5. Now you can replace x by minus x here. So we are getting minus x whole power 5 minus x. So now you are getting this minus x power 5 and minus x. You can take minus common here, x power 5 plus x. So what about x power 5 plus x? Now this is the given function f of x. So now finally we'll get f of minus x is equal to minus f of x. You are getting one minus symbol here. So therefore the function is an odd function. Now see the next example. F of x is equal to 1 minus x to the power of 4. Now we have to check whether the function is even or odd. Yes, now you replace x by minus x here. F of minus x is equal to 1 minus of minus x to the power of minus x to the power of 4. So 1 minus x power 4. So we are getting same function f of x. So f of minus x is equal to f of x. Therefore, the function is an even function. Now, this is an example for neither even nor odd function. See, f of x is equal to 2x minus x square. Now, you replace x by minus x. You are getting this minus 2x minus x square. After taking minus common, you are getting 2x plus x square. In this case, we cannot replace this 2x plus x square by f of x, but f of x is equal to 2x minus x square. Now you are getting 2x plus x square. So in this case, we cannot write f of minus x is equal to minus f of x or f of x. Therefore, this function is neither even nor odd function. In this case, we cannot determine even or odd function for this type of function. And next, to find the difference quotient for any other functions, you have to calculate f of a plus h minus f of a divided by h. This is called the difference quotient. See, f of a plus h minus f of a by h. So what about f of a plus h? The given function f of x is equal to x cube. So what about f of a plus h? A plus h the whole cube. F of a nothing but f of a cube. Now when you simplify this a plus b the whole cube formula, a cube plus 3a square b plus 3ab square plus a b cube minus a cube. So now a cube minus a cube get cancelled. You get this 3a square plus 3ah plus h square. This is called the difference quotient. And this is the example for the domain. Next one is find the limit of the function 2x square minus 3x plus 4 at the point x is equal to 5. So you have to substitute limit x tends to 5, 2x square minus 3x plus 4. Wherever x exists, you have to replace x by x 5. So 2, 5 square minus 3 into 5 plus 4. So this is the answer. When you simplify this, you are getting this answer. And next, this is the statement, a sandwich theorem. Take the two functions f of x and g of x. Now we'll introduce one new function g of x in between f of x and h of x. And a limit f extends to a f of x and limit extends to a h of x is same. That is the value is L. Then g of x is also take the same limit whenever x tends to a. This is called sandwich theorem. Now, we'll define the continuity of the any functions. So, f is continuous at the point A if the function first basically defined at the particular point, and also limit exists. Limit x tends to a, f of x must be exist, and that limit value is equal to f of a. Then only you can say the function is continuous. Now, this is an example for the continuous. Show that the given function is continuous at the point a is equal to -1 for the function f of x is equal to x plus 2x whole cube whole power 4. So the point is given. You have to check at the particular point a is equal to -1. So limit x tends to -1 f of x is equal to limit x tends to -1. The function f of x is equal to what? X plus 2x cube whole power 4. So we have to replace x by -1 here. So we'll get -3 power 4. Then -3 power 4. 3 square into 3 square 8. 9 into 9 81. So the continuity, the function is continuous because you are getting some finite value. When you are substituting x tends to -1 for the given functions, the value exists. Therefore, the function is continuous. Next, see now the previous one, intermediate value theorem. Function is continuous on the closed interval a comma b, and capital N be the any number between f of a and f of b, where f of a is not equal to f of b, then there exists a number c belongs to a comma b such that the image of the particular number c is equal to capital N. So already we took this capital N in between f of a and f of b. This is called intermediate value theorem. Next, so we have to find the points on the curve whenever the tangent line is horizontal. So this is the given conditions. The tangent line for this curve y equal to x to the power of 4 minus 6x square plus 4. This is one curve. For this curve, the tangent is the horizontal. The tangent is a horizontal means the slope value equal to 0. That is m equal to 0. So dy by dx is equal to 0. This is the given condition. So using this conditions, we have to calculate the point of intersections. So now the given curve is y is equal to x power 4 minus 6x square plus 4. So we have to find the derivative dy by dx, differentiate this given curve y with respect to x. So dy by dx is equal to, and x power 4 means 4x cube minus 12. 6 into 2, so 12x plus 4 is constant, so derivative value is 0. So already the condition is dy by dx is equal to 0 because the tangent line is horizontal. Therefore, dy by dx is equal to 0. Take this condition here, 4x cube minus 12x is equal to 0. Now take common, 4x is common. So we are getting x square minus 3 equal to 0, and x is equal to 0, x square minus 3 equal to 0. So we'll get x is equal to plus or minus root 3. So now we have the 3 points, 0 plus root 3 and minus root 3. Now substitute these x values in the equation y. Substitute x is equal to 0, we'll get y equal to 4. And plus root 3, we'll get the answer is minus 5. And minus root 3 now the answer is minus 5. Now this is points on the line whenever the tangent lines are horizontal. And next, the motion of the particle is given by, the s value is given 2t cube minus 5t square plus 3t plus 4. This is the motion of any particle. Next, the question is find the acceleration. And what is the acceleration after the 2 seconds? So to find the acceleration, so first of all, we have to find the velocity. Velocity means differentiate s with respect to the time t. So ds by dt. This is a velocity. So differentiate the given function s with respect to t. So we'll get 6t square minus 10t plus 3. The 3t or the differentiation value is 3. And what about this 4? 4 is constant. The function, this is a basic function f of x cubic root of x square plus x plus 1. So we have to find the derivative. Derivative means a df by a dx. So now the derivative of this one is, now the given functions can be written as x square plus x plus 1. The cubic root means what? The denominator power is 1 by 3. Take this function into the numerator, the power becomes minus 1 by 3. So we have to differentiate this. So minus 1 by 3 x square plus x plus 1. So minus 1 by 3 minus 1. And differentiate here. This x square becomes 2x and x or the derivative is 1. So 2x plus 1. That's all. Next, differentiation of f of x is equal to a root of log x. Same thing here, log x can be written as log x power 1 by 2. So we know that x to the power of n, the function is x to the power of n. The differentiation value is n into x to the power of n minus 1. So here f dash of x is what? 1 by 2 log of the power 1 by 2 minus 1. So minus 1 by 2. And again you have to differentiate this log x. Log x or the derivative value is 1 by x. That's all. And this is the differentiation values. F of x is equal to log of 2 plus sin x. And the differentiation value is a log of any functions. The differentiation value is 1 by x. So f dash of x is nothing but 1 divided by x. X is 2 plus sin x. And here the log is base 10. So that is log 10. And again d by dx of 2 plus sin x. Differentiate the inside the bracket term 2 plus sin x. So the derivative of 2 is constant 0 and sin x or the derivative is cos x. So this is the answer. Log base 10. So whenever you are differentiating this 1 divided by log x, that is log x or the derivative is 1 by log x into log 10. To find the extreme value. Extremum value means either maximum value or minimum value. If f is continuous on the closed interval a comma b, then f attains absolute maximum value f of c and an absolute minimum value f of d at some number c and d in a comma b. This is called the extreme value theorem. And next is a Fermat's theorem. If f has the local maximum or local minimum at the particular point c, if f dash of c exists, the same time f dash of c equal to 0. This is called a Fermat's theorem. F has a local maximum and a local minimum at a particular point c, and also the derivative f dash of c exists, then the derivative values is equal to 0. This is called a Fermat's theorem. And the condition for the absolute maximum and minimum. The absolute maximum of the function f on d means if f of c is greater than or equal to f of x for all x in d value. This is maximum. The function is the absolute maximum of f means what? At the particular point c means that f of c only the maximum. Whatever the values x in belongs to, D. Then absolute minimum value of D similarly we will define if f of c is less than or equal to f of x for all x in D. Next, they explain the condition for the local maximum and the local minimum values. The local maximum means for the any function f, you have to calculate first f dash of x. And we have to check the condition f dash of x positive to minus negative values. Then the function, given function as the local maximum. Or whenever the function f dash changes from a negative to positive, then the given function f as the local minimum. Local maximum means a positive to negative, and local minimum means f dash changes from negative to a positive. Okay, this is condition for the local maximum and minimum. Next, first derivative test. This is first derivative test. Suppose that c is the critical number of continuous functions f. The condition is if f dash changes from positive to negative at the particular point c, then f has a local maximum. And f dash changes from negative to positive, then f has a local minimum at c. If f dash does not changes at c, then f has no local maximum or minimum at c. This is the condition for local maximum minimum. This is called the first derivative test. And next, the condition for concavity test. To find the condition that the curve is concave upward or concave downward, for the given functions, we have to calculate first derivative f dash of x, and you have to check whether the function f dash of x is strictly less than 0 for all x in the given interval. Then the graph of f is said to be concave upward. That is, the first derivative is less than 0 means what? Negative values for all x. Then the graph is said to be a concave upward on I on the given interval. Or if f a double dash of x is greater than 0 for all x belongs to I, then the graph of f is concave downward. That is here. This is not first derivative, first condition. F double dash of x. So calculate the second derivative. So f double dash of x is less than 0, then the graph of f is said to be concave upward. And f double dash of x is greater than 0, then the graph of f is said to be a concave downward. Downward means f double dash is greater than 0. Upward means f double dash of x is less than 0. This is the condition for concave upward and concave downward. Next term, inflection point. A point P on the curve y is equal to f of x is called the inflection point. If f is continuous and the curve changes from concave upward to concave downward, or from concave downward to concave upward at a particular point, then this point P is said to be an inflection point. So to find the inflection point, so we have to check first for the given functions, we have to calculate a second derivative f double dash of x, and we know that if f double dash of x is less than 0, then the graph of f is said to be a concave upward. If f double dash of x is greater than 0, then the graph of the given function is a concave, a downward. Next, so find out identify the particular point, and that point only the function is changes from concave upward to concave downward, or concave downward to concave upward. So take the identify the particular point. That point is called the inflection point. And next, this is called a second derivative test. Already we have seen the first derivative test, and this is the first derivative test. So for the first derivative step, what are the conditions? This is called first derivative test. Calculate first derivative for the given functions f dash, and we have to identify f dash of x from positive to negative. We can say it is local maximum, and negative to positive, you can say the function is a local minimum. Right? This is the first derivative test. Now we will see the second derivative test. For the second derivative test means we have to calculate the second derivative f double dash for the given function. And find out f dash of c equal to 0. So for the given function f of x, calculate the first derivative f dash of c equal to 0, then find out the point, and then find out the second derivative value f double dash of c greater than 0. Then the function as the local minimum at c. So whenever the double derivative is greater than 0 means the function as a local minimum. And same thing here, f double dash of c less than 0, then the function as a local maximum at c. So already we have seen the concave upward and downward. Concave upward means f double dash of x is less than 0 means a concave upward. F second derivative is less than 0, then f is said to be a concave upward. Here, f double dash of is less than 0 means f as a local maximum. So now f double dash is less than 0 concave upward, and f double dash of c less than 0 means the function as a local maximum. Concave upward means it is equivalent to, nearly equivalent to the function as a local maximum at c. Similarly, f double dash of c is greater than 0, then the function is concave downward. So here f double dash of c is greater than 0, the function is a local minimum at c. Now this is the second derivative test. Next, see this. If f of 1 is equal to 10 and f dash of x is greater than or equal to 2, the x value is defined only in 1 to 4. How small can f of 4 possibly? See, now we'll apply the mean value for theorem for this. So what is the mean value theorem? F dash of c is equal to f of b minus f of a divided by b minus a. Now here a comma b is a given interval. In the given problem, here a is equal to 1 and b equal to 4. So calculate what is f of 4 and f of 1. So here the function is not given. The value is any other function is not given. So we will consider f dash of c equal to f of 4 minus f of 1. divided by, but we know the b and a value, so b minus a, 4 minus 1 is equal to 3. But what about f of 1 value? F of 1, the condition, given condition, f of 1 is equal to 10. So now f of 4 minus f of 1 is nothing but 10 divided by 3 is greater than or equal to. So why this is greater than or equal to 2? Because your f dash of x, the derivative value is greater than or equal to 2. That is a given condition. Therefore, we will consider f of 4 minus f of 1 divided by 3 is equal to f dash of c. You know that f dash of c is greater than or equal to 2. So that's why we are considering this value is greater than or equal to 2. Therefore, f of 4 minus f of 1. So what about f of 1? F of 1 is equal to 10. So f of 4 minus f of 10 divided by 3 is greater than or equal to 2. The next step, f of 4 minus 10 is greater than or equal to this 3 into 2, 6. So now f of 4 is greater than or equal to this minus 10, take it to the right side, plus 10, 6 plus 10, 16. So now your f of 4 value is greater than or equal to 16. So the question is, how small can f of 4 possibly be? So f of 4 the value is 16 or more than 16. So 16, 17, etc. So in that value, we select the smallest value. So 16, 17, etc. up to infinity. So the minimum value of f of 4 is 16. This is a small value for this f of 4. So 16. And then next, calculate d by dx of sin x whole power of cos x. So for this type of functions, we have to write the given function as, so this is of the form x power x. To solve this type of problem, we can write the given function as e to the power of log. So we know that e to the power of log is 1. So taking the power e to the power of log. So now this sine power cos x can be written as e to the power of log of sin x over x. And now this sin x power x can be written as a log m power n formula. We can apply here. So log m power n can be written as n into log m. So now this can be written as e to the power of mn, log m power n. So n is here cos x. So this can be written as n into log m. So e to the power of cos x into log sin x. Okay, the given function sin x power x can be written as e to the power of log. We can take e power log, we can introduce this e power log. Then only you can solve the sin x power x problem, cos x problem. Because base x and power is also x. In this case, for any problem x power x, yes, for any type x power x problem, base x and power x. To solve this type of problem, we can write the given function as e to the power of log into given functions and apply log m power n property. So n into log m. So now this is e power cos x into log sin x. And we have to differentiate now. So now d by dx of it. So you know this function is of the form e power x. So you consider the whole power cos x into log sin x is x. So now this is e to the power of x. So we know that d by dx of exponential function, any e power anything. So the value is same. So e power x, the differentiation value is e power x only. So therefore, d by dx of e power, this value is same value. So e power cos x into a log of a sin x. And again the differentiate the power. So see the power. In power is the terms are in product. So take the first term is u and second term is log into sin x v. So now you have to differentiate this. Apply the product rule. U into v dash plus v into u dash. So cos x into, differentiate this. Log sin x or the derivative value is 1 by log x. Log x or the derivative is 1 by sin x. Again differentiate the sin x. So we'll get cos x plus log sin x, and the cos x or the derivative value is minus sin x. Okay. So now this cos into cos square x by sin x, and this plus into minus sin x into log sin x. And again the given function, this is e power cos into log sin x. The original form is what? Sin x power cos x. So we can replace again. The given one is sin x power cos x into cos square x by sin x minus sin x into log sin x. Next, now in the 16th problem also, find the derivative of f of x divided by cubic root of x square plus x. So for this type of problem also, you can substitute the substitution method. X square plus x plus 1. You can consider this as some other variable. X square plus x. Okay, you can substitute t. And this also 19th problem also, root of log x. You can substitute log x is equal to some other variable t, right? Then we can solve as usual, right?